Hey there, my name is Alejandro, and welcome back for day 225 of me doing Daily LeetCode challenge. I'll tell you 1 year's worth of green contributions here on GitHub. So today's problem is for February 26, 2025. Without further ado, let's get straight into it. Okay, today we get LeetCode B problem 1749, maximum absolute sum of any subarray. You're given an integer array nums. The absolute sum of a subarray, nums, okay, is absolute value of nums plus nums, okay. Return the maximum absolute sum of any possibly empty subarray of nums. Okay, note that absolute value of x is defined as follows. Okay, if it's negative, then it's okay, sure, yeah. Okay, let me check one thing. Yeah, okay, it's gonna be linear size. Okay, I was gonna say, all right, yeah. Okay, so just like in yesterday's video. Oh, by the way, I'm not signed in. Let me just make sure that that happens real quick. Is it gonna ask myself? Okay, just give me 1 second. Okay, so sorry about that. I'm now signed in. Okay, beautiful. Yeah, what I was gonna say is like yesterday's video. Essentially, if you do prefix sums, you're able to get the subarray sum of any subarray in O of 1 time, right? So we can just do something like that. So here, we'll do prefix sums is equal to this. Cur sum is equal to 0 for num and nums. Cur sum plus or equal to num. Prefix sums dot append cur sum. This time is important. And here we'll do. Okay, here we'll do get subarray sum equals lambda I comma j prefix sums of j minus prefix sums of I minus 1 if I greater than 0 else 0, right? And here we'll say what do we want? Maximum absolute sum of any subarray. Okay, return max of get subarray sum I comma j, and here we'll do we'll even do absolute value of this for I in range. Here we'll say n is equal to length of nums. For j in range I comma n, right? We can have length 1 subarrays, that also works. Yep, so something like that works, but I'm gonna guess that when we submit this, this is going to time limit exceed, right? Because this is an O of n squared solution. And there we go. Okay, exactly as predicted. We TLE at 54 out of 66. Okay, so, all right, so we need to figure out how to do this in O of n time. Okay, so in yesterday's problem, we had a similar problem where we also had a linear, we wanted like, you know, the number of subarrays that have an odd sum, right? And we needed to do that in linear time. And yeah, so obviously it was very trivial in n squared time. And that one we resorted to dynamic programming based on index, right? Because it's like, okay, if we got to do something in linear time here, or n log n time maybe, then you might as well, okay, we're probably not going to sort or anything just because it's like subarrays. We probably want to do like, you know, count stuff from a certain index I, right? And then it's like, you know, if you do O of n work for every single index I, then that's O of n squared, so you can't do something like that, right? But if we think in terms of DP, maybe there's recurrence relations that we can do, right? Okay, the very first thing I noticed is like, yeah, so this is absolute value of all the sum of the numbers, right? Otherwise, we could use something like Cadane's algorithm, where it's like, you know, if it was absolute numbers, absolute value of the numbers themselves, right? Like, you know, absolute value of this plus this plus this plus this, you could just turn every single number in nums to be a positive version, and essentially, you know, use Cadane's algorithm. Ooh, wait. We could. Oh, wait. This could be something like yesterday, actually. Is Cadane's algorithm basically like DP? Yeah, like maximum subarray sum. If I come into LeetCode over here, that's a DP problem, right? Or is maximum subarray sum a greedy problem? Okay, maximum subarray, so okay. There might be a DP way of solving that one. Yeah, okay, let me come back to this. I see, because I just got an idea, which is like, okay, if you want to do maximum subarray sum. Wait, no, I can even do better than that. I was thinking of like, you know, like in yesterday we kept track of like, you know, the number of odd sums and even sum subarrays from an index I to essentially help us to the next one. Here we could just do maximum subarray sum as well as minimum subarray sum. And then out of the two, like whichever one has the biggest magnitude when you absolute value. Wait, that's literally, okay. I mean, okay, we can try that. Def, you will just say, idea, we want largest subarray sum. Why not get largest subarray sum, smallest subarray sum, take the larger of the two There we go. Here we'll do max subarray sum self, comma, nums. Return max of array sum of nums self dot max subarray sum of map and the x comma negative x comma nums. And here we'll just do I guess we'll do absolute value just because it's like it could technically be a positive value. Although doing a negative sign will also work just because it's like it'll inevitably be less than or equal to this one and so on. So okay, but either way, just for the sake of like, you know, paranoia, we can do absolute value. Here we can just do we can do something simpler. Negative num in nums, right? So let's just do something like that. Def max subarray sum nums, right? And for something like this, we can just use Kadane's algorithm, right? Is it Kadane? No, yeah, Kahn's algorithm is for topological sorting. Kadane's algorithm is for maximum subarray sum, right? This just basically says like, you know, compute the current subarray sum. At any point, if you're negative, just stop, right? So here, what will we say? We'll say cur sum is equal to 0 for num in nums. Res equals float of negative infinity. Plus or equal to, okay, length of nums is at least 1, right? Here we'll just say nums of 0, why not? Default value. Plus or equal to num. Res less than cur sum. Res equals cur sum. Cur sum less than 0. Cur sum equals 0. Turn res, right? Something like this. Okay, that's accepted. Let's submit. And there we go. Goes to strict 225 days. Consistency is key. See ya tomorrow. Okay, yeah, this is not even dynamic programming. This is just straight up greedy. Okay, nice. Lol. Okay. I was thinking way too hard in terms of yesterday's problem. All right, sweet. Yeah. Okay. And yeah, if I did a negative sign, like my hypothesis will be true, right? This will work, not for the reasons like, you know, you would expect. Oh, actually, there's a case where it doesn't work and so on. Okay, I stand my case rested, right? Because I was like, you know, maybe if this is positive and so on. Okay, absolute value, you know, for sure it makes sense anyway. So it's like, might as well keep it that way. But like, you know, the point is that like, you know, the small subarray sum might be negative, might not be negative, and therefore it might make things weird and so on. So, you know, might as well just keep it absolute valued, and there we go, right? So yeah, one thing also is we could do things in one parse. Instead of this, here we'll say cur pos sum, cur neg sum equals 0, 0. Res equals nums of 0. For num in nums, cur pos sum plus or equal to num. Cur neg sum minus or equal to num. If res equals max of res plus sum. Cur pos sum less than 0. Cur pos sum equals 0. Next sum equals 0. Does this change anything? I might have to do this the other way. Yeah, so what if I did this? No, this doesn't make any sense. Right, so here's like all the numbers will be negative. So yeah. Okay. Oh yeah, because I'll be subtracting. When I subtract negative numbers, things are nice. Yeah. Okay. Makes sense. Okay. Yeah. That makes a lot of sense. Right. Okay. So now if I submit something like this, is being chilling. It takes longer now? What? Oh, yeah. Cur pos sum equals cur pos sum. Res less than cur neg sum. Res equals cur negative sum. There you go. This will make things faster. Oh, and since we can take the absolute value sums, okay, yeah, there we go. 0. Since we can always take absolute value of any subarray, 0 is smallest possible result. That way we don't even have to look at nums at index 0. Okay, but yeah, now we're around 19 ms and so on. One pass solution O of n. There we go. These should be put together. Update res, reset current sums, and return res at the end. Yeah, and there we go. Okay, beauty, very beautiful. Okay, and there we go. 15 ms beats 96%. That's absolutely what we love to see. Bada bing, bada boom. There we go. Okay, so as always in all my videos, I do a quick recap if I was able to solve the problem. So for this one, essentially, okay, you know what? For once, let me actually do a very quick explanation. Essentially, this is Kadane's algorithm. Kadane's algorithm is all it does is finds the maximum subarray sum. This is a problem that I know very, very well. It is one that I did inside of the LeetCode 150 problems over here, maximum subarray. And there's a well-known algorithm called Kadane's algorithm for finding the maximum subarray sum. In this problem, we want the maximum absolute sum of any subarray. Basically what I realized is like, okay, since we want the largest absolute sum, it's going to be one of two possible cases. It's either going to be what is the current largest subarray sum inside of nums, right? Because maybe that's the biggest, or the smallest sum that I can get in nums, because the smallest one might be so small that it's a very small negative number that when I absolute value it, ends up becoming a huge positive number, right? So there's only two possible cases. It's either going to be the largest the largest subarray sum in nums, right? Or the absolute value of the absolute smallest subarray nums, because it could be like a very tiny negative number that becomes when absolute valued a huge positive number that's bigger than the without absolute value biggest subarray sum in nums, right? sorry, there's like a light beam of light over here just flashing and so on. I don't know how to get rid of it. Okay, maybe if I like dim the lights a little bit. Oh well. Okay, it's like very cool. I'm like doing superpowers right there. Okay, very nice. Physics, my friends. All right, but that's pretty much literally the algorithm, right? I write a helper function over here that gets me the maximum subarray sum in an array. This is Kadane's algorithm. If you're not familiar with it, essentially it's like, okay, you're gonna keep track of the current sum. Initially, you're gonna start with 0. You're gonna start with, like, you're gonna set res is equal to, like, the very first number and so on. The reason why you don't want to set it to 0 or something, you can set it to float of negative infinity if you want, but the reason why I do the first number is usually with a subarray, right? Let's say that all the numbers are negative. In this case, like, there's absolute values, but let's think about, the traditional maximum subarray sum problem. If all the numbers are negative, you can't even have 0. So like 0 is like, an overestimate of the largest subarray sum and so on. So that's why I like starting with the very first number. But otherwise, like, for every single number in nums, what we're going to do is we're going to add that to our current sum. If res is smaller than the current sum, update res to the current sum. Now, here's the thing. If the current sum is negative, right? Here's the thing. Since the current sum is negative, we can just scrap all the elements that are in the current sum subarray, right? And just start a new one. Right? That's kind of the greedy part of this algorithm, right? We're going to keep track of a current sum always, initially starting with 0, but adding at least the very first number, which might bring us to the negative region. And then, like, we update res every single time in case it's smaller than the current sum. And then we say, okay, if the current sum is currently negative, since we want the largest current sum, let's scrap everything we have, reset this bad boy to 0, and just keep going from then on, right? And that way you'll end up reaching the maximum subarray. I mean, it doesn't matter how you do this. This is just one way of doing it. This is Kadane's algorithm, and it's like just it just happens to be an algorithm, I know. And yeah, and then in terms of that, then I essentially problem reduce this problem. I realized, like, okay, we want the maximum absolute sum of any subarray. So it's either we want the largest subarray or we want the smallest subarray, absolute value, right? So here I said, okay, return the maximum between the regular maximum subarray sum in nums, right? And the absolute value of the maximum subarray sum, using the same function, but of the negative version of every number in nums. Because that way, that'll essentially get me, like, if I do the maximum subarray sum with all the negative numbers in nums, I effectively get, like, the smallest subarray sum in nums, right? Because I'd be trying to get the largest possible number from the positive numbers out of nums after their signs have been flipped, which will be the largest, the smallest negative number I could have gotten from the original nums that I then absolute value, right? And so between these two results, I return the maximum one of them two, and it happens to be a nice and efficient solution. Now, I just realized that I could do things in one pass, right? I'm essentially calling this a function, but with one, I'm using the negative numbers version of the numbers, and one version I'm doing the positive numbers, right? So that's why I kept track of, like, current positive sum and current negative sum, 0, 0, right? And then res is initially equal to 0. The reason I do 0 and not the very first number is since we want, like, the maximum absolute sum of any subarray. Think of any subarray you take, since you're going to take its absolute value, the absolute smallest possible value can be is 0, right? And there's at least one number in here, so I know that 0 is the absolute smallest possible result we could ever get. That's why I'm not scared of putting 0 for res, right? Then I just loop through every single number in nums, and I do the same thing as before. Current plus of is plus or equal to num, but remember, for the other one, we have the negative version of the nums. So here I'm going to subtract the negative sum, right? The point is that I'm trying to get them, after I flipped all the signs and numbers, let me try to get the largest possible sum, because the largest possible sum will essentially reflect the smallest possible sum that would have then been negative with the regular nums, right? So I do current negative sum minus or equal to num. Then it's like, okay, update res if it's smaller than either the sum. So if it's less than current plus sum, set it to current plus sum. If it's less than negative current sum, then set it to current negative sum. So if it's smaller than any of those, just set res. And otherwise, reset these guys, right? So if current plus sum is less than 0, then set current plus sum to 0. Right, kind of like how we were doing here in Kadane's algorithm. If current negative sum is less than 0, then set it to 0, right? If anything, one thing I could do is I could merge these if statements, so that way it's like I only have 2 else ifs instead of 4 ifs, right? So if current plus sum is less than 0, we'll do that. Otherwise, we'll do elif res is less than cur pos sum, because it's a positive number. We'll just say res is equal to cur pos sum, right? And then same thing. If current negative sum is less than 0, then we'll update it. Otherwise, if res is less than current negative sum, we'll just say res equals to current negative sum, right? And this will just help beat us a little bit of the O of 1 stuff, right? But not really make too dramatic of a difference, right? And there we go. So we can run this, And just like, right now we have 15 ms. It might help us get a little bit higher, a little bit lower. We'll just have to see. So yeah, so now we're at 11 ms, beats 98.05%. Mwah, chef kiss. There we go. But yeah, that's pretty much it in terms of how I solve this problem. So I know that in my videos, I oftentimes I realize I take 30, 40, 50 minutes to explain some of my solutions. So I kind of want to make an effort to hone that down, right? Right. Even right now, trying to make it short, it's probably like a 10-minute explanation, right? Which is just crazy, especially for not that much amount of code in a problem that I was able to solve reasonably fast. So just quick recap, essentially Kadane's algorithm to essentially find the maximum subarray sum of any array. Then I recognize since we want the maximum absolute sum of any subarray, which is take any subarray sum and then you can absolute value it, is either going to be the maximum subarray sum in nums, or it's going to be the smallest subarray sum in nums after I absolute value it, right? Because the smallest subarray sum could be such a small negative number that when I absolute value it, happens to be such a huge positive number and maybe bigger than the current largest subarray sum in nums, right? So it's going to be one of those two cases, either the largest subarray sum or the smallest subarray sum absolute valued. Take both of those cases, return the maximum one, and there you go, chop chop, you have a nice and efficient solution. And yeah, so hopefully that solution makes sense. But otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So till then, ciao ciao, my friend. Bye-bye.